This is from her text. The creature that the creature that stares at you from your plate of meatballs is not an amphibian beagle. It is a ubiquitous surveillance of networked image production, a type of memetically modified intelligence that watches you in the form of lunch, right? And this comes from this original image, which was made with the Deep Dream, where the Deep Dream, and so let's just to say what this is doing is it's a common visualization technique that engineers use in order to determine what their model knows. So what the Deep Dream does is it starts originally with a full image of just noise, and it has a program that goes by each grouping of pixels. It usually takes like a square amount of pixels in the top left, and it optimizes those pixels to be a certain label. So you could tell it to look for faces and everything, and it will optimize the noise to become face. That's how. And so what it does is these basically these are hyperbolic examples of what it sees. And once it starts to see something, then it engages it over and over again in recursive loops, and that's why we get these pictures out. This looks like it's a dipping, diving road, but it's not. It's actually not. That's actually data. That's reality for the image. But the problem is that these are two perspectives that are clashing at one time that we're recognizing at the surface. Okay, one is our perspective, which is this like, which the computer calls it like a world coordinates, like, so it can recognize the spatial representation and its statistical measurement. When it tries to translate to human readable, it literally comes out like this form. And there are different, like, one is the computational perspectives, another is like the actual, like, the actual shape of the earth, if it's not actually round. But yeah, so if you look through, though, there are like so many of these perspectival issues happening in Google Earth. So this is like a great example of how we do not see like computers, even when a computer is trying. And there are other ones, I think there's like there's ones with cities too, where the cities are actually at two different coordinate systems. So they're actually like in a 3D world, they're actually not, they look like a Escher style. And so this is actually like, this is the clashing of our two perceptions. You brought up something in context, or when you were trying to bring up the concrete example, and I wanted to say there was an actual, there's an actual like study that's really interesting about this, in that I was saying that we constrain systems down to minimal tasks in order to produce answers that we can say that they are. And even if we do, we can give the most structured rules. And it's quite interesting when AI follows the rules but breaks the reality of the world. So an example is, they were training on the game Doom, the computer game Doom. They were training an agent to block the projectiles that were coming after them. And the agent figured out that if it just kind of jittered like this back and forth, that the enemies never shot a bullet. Therefore, it never gets hit, so it's always avoiding. So the problem is like circumvented by the AI itself, because you're thinking, okay, don't get hit by a bullet. That means that the bullets are coming after you. But this thing figures out, no, the program means that if I do this, nobody will shoot at me. So that's the answer. So yeah, there's like these unplanned things, and no matter how much you plan them, it's impossible. And the way that these images work is that they represent the data in the image in two different understandings, uh, which is one is content style, one is content, and the other is a style. And so now this is where people like I think us would go into it and start to think about like how did they even determine what style is in an image, because like in it, and you can learn that very basic understanding of what aesthetics is that they kind of that they that they that they do, but they don't care about the actual concept. They care about the fact that whatever they did, like output something that visually looks like it's doing what it does. So if whatever they do, they just kind of like what they care more about is like they see everything in math, and they're just manipulating math, and it just comes out to being what is right. There's probably not a lot of theory in a lot of the ideas, but let's talk about this. So this you can take any style from any image and basically translate them. Works on video. If you can do any image, you can do video, because a video is just a sequence of images. You just need to break that down. StyleGAN has a lot of really cool models already out there. StyleGAN 2 pre-trained models. Justin Kennedy orders in this. All of these here are models you can download and use. So there's a nice car data set, another car data set. Cats and dogs are everywhere. There's a lot of cats and dogs. You'll find cats and dogs in almost everything. Church data set. A lot of different face data sets. You're going to notice that this is like the common terminology, high quality facial features. There are a lot of different versions of these, like this faces, these ones, different configurations, right? And then there are also like, there are racial ones, there are gendered ones, there are a bunch of different ones that you could kind of play with to see which one you like. If you like horses, ImageNet is Google's main image data set. Adam Harvey, who we've mentioned right in the beginning, Veronica mentioned his art. He actually did a project that I think it's ImageNet, that showed the bias in a lot of the labels of, I think it was ImageNet or Coco, one of these early data sets. But this one is the one that's used in Deep Dream too. ImageNet is the model that's in Deep Dream. And ImageNet has a ton of dogs for some reason, and a ton of cats, a ton of birds, a lot of animals, because the animal classifications, there's many ways to argue it. Yeah. So ImageNet is kind of a general. It has 1,000 categories, which I can also I can give to you. ImageNet is a different kind of model. So the model has like an image based with a classification of a label. So it's a conditional model based on that. So you can give it one of the 1,000 numbers, and it will generate your images for you. This is a Wikipedia art database of all the Wikipedia stuff. Anime portraits, microscopic images, this one's fun to use. I like this one. Wildlife, modern art, trypophobia, abstract, maps, cakes. Anyways, these are the ones just hosted here. But they're like the most used common models.